At a glance of this, we should be able to deduce that the mean mark for the boys has to be higher than 60. Because if it is lower than 60, there's no way you're going to get a mean mark for the whole class of 60. It kind of needs to balance out with the girls. And if the girls is 6 lower, then the boys must be higher. In fact, we can do this instantly. If this is 6 lower, and there's twice as many girls, that downwards of 6, that's basically getting multiplied by 20, in effect. But if we want to increase it by the same amount as that's decreased, but do it less, then we're going to have to be double that difference. So we're going to have to be 12 higher. So it's going to have to be a mean of 72. But this isn't really a standard technique. This isn't, well, I wouldn't really advise it that much unless you really understand what you're doing in means. So instead I'd take the approach of thinking, what is a mean? Now if I want to calculate a mean, I divide the total of all the values added together, divided by the number there are. This isn't helpful at the moment because we've got the number of boys, but we don't have the total for the boys. But we're given this information here, and intuitively with exam papers, we have to use all the information which we're given. So we need to think, how can we use this information to help us work out this total? If we were to rearrange this equation, we can times both sides by n. So the total is going to be the mean times by the number. It's basically just undoing this and giving us a total instead. So if I was to put all the marks together, this is the total for the whole, then this could be the boys, this could be the girls. Looking at it visually like this, if we wanted to work out the total for the boys, we can subtract the total for the girls away from the total for the whole class. Now I'm going to use this framework here when I'm progressing. So I'm going to put everything over 10 straight away because that's what I'm going to be doing. And I want to express the total here. I've established that I'm going to be doing the total for the class, minusing the total for the girls. The total for the class is going to be 30 times by 60. 30 because there's 30 people in total in the class. 10 and 20, that's 30. And we're timesing that by the mean for the class. And from that we're going to subtract the amount for the girls, which was 20 lots of 54. Now all we need to do is simplify down this equation and get a result. Now I could, if I wanted to, do 30 times 60. That gives me 1,800. 3 times 6, that's 18. I'll basically times both of these terms by 10. So in total, this is going to be times by 100. And I could also do 20 times 54 if I wanted to. So I'm going to do 10 times 54, that gives me 540. Times that by 2, I get 1,080. Subtract those, divide by 10. You get the idea. It's we're going to get a result, but there's a shortcut we can do here, and we can actually break up this fraction into two separate fractions. So I can divide this by 10, and then divide by this by 10. That's actually going to give me the same result. So now I'm just going to get 3 times 60, which is 180, and then 2 times 54, which is 108. So I applied a little bit of a shortcut here where it actually cancelled out. I cancelled out this 10 with this here, because if I do divide this by 10, I can just divide one of the parts of a multiplication by 10, and that's going to have the overall effect of dividing by 10. And again here, I cancelled out by 10. And now we can just do this in our heads if we want to. We could just think, what do we add to 108, or try to subtract this in our head. Maybe subtract 100 and then subtract another 8. But if you're not comfortable with that, then we can do a good old trusted method of doing written full method. That's going to cancel down to a 7, 2, 7, 0. 72. That was the number we were looking for.